Okay, hey, Alg3 kids. So today's topic is we're going to be adding and subtracting rational expressions. And in these notes, we'll add and subtract rational expressions, which means we must learn to find common denominators for them so we can solve problems that have rational functions. Warm up, please. Add and subtract the following expressions that are underneath my blue. Pause your video up if you want, and then do the problems. They're just arithmetic, and then come back and check them. Okay, so let me swipe this out here, and then let me see if I can get rid of this. And I should have the answers under there. There we go. Okay, I missed a couple of them here. It looks like I have -4/5. Let me make my pen a little more appropriate here, and just a regular pen. So we have -4/5 here. And so we can write that as -4/5 for this one. Might have erased some of my answers there. And okay, so with that in mind, then here we have 5/8 here. So if you got 5/8 for your problem there, and 41/21, -4/5, 22/15, and then -33/8. One of the things I did on the corner here was say that maybe if we had, there's a 2 here missing. So what we can do is we want to find a common denominator and just multiply the denominator by the other denominator. So if we have 2 and 8, we can multiply 2 by 8/8, or the first fraction, 8/8 times -9/2, and then we could take 3/8 and then multiply by 2/2. Remember, those fractions are equal to 1, so we're not changing the value of the fraction, -9/2 or 3/8. Then we get a common denominator of 16, and we add the numerators together, we get -66, but then we can divide the numerator and the denominator by 2, which gives us the same thing, -33/8. So sometimes people prefer that. So remember that when we multiply the denominator to get a common denominator, we should multiply the numerator as well. So then we had this next section where we are gotta go out and go back in. So here you want to list any factors that can cancel. If nothing can cancel, we write NA. So the first problem, number 1, the x plus 5s cancel. They're factors that cancel. Which factors cancel? Number 2, the 4s will cancel. We have 16x, which is 4 times 4x, so 4 will cancel from the numerator and denominator. And then with 3 plus x plus 2 over x plus 2, x plus 2s do not cancel because they're not common factors. So if you realize that this fraction above simplifies to x plus 5 over x plus 2. Now, if we had this situation, 3 times x plus 2 over x plus 2, then we could cancel those factors of x plus 2. So number 4, there's no factor that cancels. You might think you can cancel 5, but again, that's the yucca rule. You can't cancel over addition because there's a plus 5 in there. It's not x times 5, it's x plus 5, so you're done there. And then the x plus 3s will cancel for number 5 because they're common factors that cancel. And then we have 4s, and then the a's also cancel here. So the 4a is the one that we're canceling. Okay, so now remember, we're not simplifying these. All we're doing is saying which factors cancel. So just a little bit of review. And then what we're going to do is we're going to add and subtract fractions. So we need a common denominator. And if you notice, now we have variables in the mix. So with problem number 1, and then you want to think, does the denominator change when you add or subtract? And the answer is no. You might want to change it to get a common denominator, but you don't change the denominator. So all we're going to do is say, just like with the number problems, the problems where we were just doing arithmetic above, we're going to add the numerators, or subtract in this case, and keep the denominators. So we end up with 10 over 5x. And then we have a factor of 5 that will cancel. So where we have 5 times 2 over 5x, and it's 5 times x, so we can cancel the 5s, and we're left with 2 over x. Nice simplified expression, 2 over x. Okay. All right. For number 2, right, for number 2, we have a common denominator, so we're going to do the same thing, but we're going to add 3x plus 1, and then the denominator stays the same. We have 2x plus 5. Now, there are no common factors between the numerator and the denominator, so we're finished there. Life is good. Okay, and then with problem number 3, we have x squared over x minus 2 minus x plus 2. So I'm going to be careful with this one. I'm going to combine the numerators, but I'm going to say x squared minus the quantity x plus 2. So you'd be wise to use the parentheses because sometimes we forget to distribute the negative sign when subtracting. So we have an x minus 2 here. So now remember that I told you that what you can do is you can change subtraction to addition of the opposite, and you distribute the negative sign to both terms. So then we've got now x squared minus x minus 2, and that's over x minus 2. Now then you might wonder, can I simplify that any further? Only if you can factor, cancel, and simplify again. So we're going to try that, okay? We're going to try, do we have a factor of x minus 2 in the numerator? But we're going to factor it. So to get an x squared, we have x times x. And to get a 2 for the last term, we have a 2 times 1. And the middle term is minus x. So remember, we have to add these two numbers together, but we need a negative 2 for the last product. So it's got to be either negative 2 times positive 1 or the reverse, positive 2 times negative 1. As it turns out, this works. And remember, you can check your FOIL if you want to. Here's your first, here's your outer. So your first is x squared, your outer is plus x, and then your inner is going to be minus 2x, and then you have minus 2. So that would combine to give you the x squared minus x minus 2. So you're ready to go there then, okay? So the polynomials was the last chapter. So when we cancel these, we get simply x plus 1. Now I'm going to leave the discussion of the restrictions on the variable out of it for right now. Although x can't be 2 for this problem. Well, we might as well say it. X cannot be 2 in this problem. Just as in above, x can't be 0. Because x is in, if you put 0 in the denominator, you're going to get 0, and it will be, your fraction will be undefined. Same denominator again, and subtraction for number 4. So remember, you can pause your video if you need to review any of these or rewind it. We have 4x, and then we're going to subtract the quantity 2x plus 7, like so, and that's over x plus 3. So we have the same denominator, combine the numerators. So we end up with, let's do the same thing we did before, and we'll do addition of the opposite. So we end up in the numerator, we have 4x minus 2x is going to be a 2x, and then we just have a minus 7. And then in the denominator, we have an x plus 3. So our answer is 2x minus 7 over x plus 3. Okay? And we can state that x cannot be negative 3. I'm just going to leave that go. I think I need a new tip for my pencil. Okay, and let's move down. So adding and subtracting with one more step to get a common denominator. First, we want to find an LCD. We want to factor each denominator, and then one of each factor to the highest degree that it occurs is what the LCD is going to be. And then we're going to multiply to create the common denominator, add or subtract numerators. So now we have a common denominator. We go back to adding or subtracting numerators and then simplify. So here's what we're going to do. The LCD is going to be x plus 2 times x plus 5. Okay, and we have those properties of addition and subtraction over there where we're getting a common denominator. So that means I'm going to take my first fraction, x over x plus 2, and I'm missing the factor x plus 5, so I'm going to multiply that by x plus 5 over x plus 5. And then I'm going to add 4 over x plus 5. And then, you see, I'm going to highlight this, in fact, on the first one. So I'm multiplying by 1. So I'm keeping that first term and multiplying by 1. And then I'm keeping the second term, and then I'm going to multiply by, oops, something went wrong there. So the second one, so here. So I'm going to multiply the second one by a factor equal to 1, but I need the denominator, I need to have that x plus 2. So I'm going to multiply by x plus 2 over x plus 2. And then I've got to bring these together. So it's x times x plus 5 plus 4 times x plus 2. I'm going to take that step and I'm going to put them over the same denominator, but I'm going to put it in factored form that I have x plus 2 times x plus 5. Okay, now I'm going to distribute each one of the groups, and so that gives me x squared plus 5x plus, then I'm going to distribute here 4x plus 8, and then over x plus 2 times x plus 5. Okay, so now I'm going to bring the top together where I have x squared plus 9x plus 8. And that's over x squared. Now, I'm going to take a second over here and see how this factors. So it factors as x plus 8 times x plus 1. So that's not going to cancel with anything in the denominator. So what I'm going to do is I'm going to take this denominator, I'm going to multiply it through as x squared, and that's going to be 2x plus 5x. So that's going to be a 7x plus 10. So my final answer is this. But to tell you the truth, once you get this numerator, you could give me x squared plus 9x plus 8 over this x plus 2 times x plus 5, and I would accept it. What you really need to understand is how to put it in that last form in case you're required to do so. Okay, so there's our answer for that one. We're going to try one more here. So I'm going to factor everything first if it can be factored, but I only have one term that can be factored. So I've got a 4x over x plus 3, and that's going to stay there. That's not going to change at all. And then I have this 2x plus 7, but I can factor the difference of two squares, if you remember from the past chapter, that would factor as two binomials, x plus 3, x minus 3. Okay, the difference of two squared. And I'm going to take, it's nice to be on the iPad because I can kind of squeegee something in there, here, like so. So I'm going to multiply that first fraction by the missing factor. The LCD, let me do this first, is x plus 3. So that must be a factor of the LCD. And you can see the x squared minus 9 has the factors x plus 3, x minus 3. Well, I already have this. I already have the x plus 3, so I just need to add on the x minus 3. So the missing factor over itself is what I'm multiplying that first fraction by. Now, I'm going to bring things down. Remember, I'm going to multiply those. And the denominators, I'm going to leave them in factored form as I go through this. So I get the following. 4x squared, I distribute here, minus 12x minus the quantity 2x plus 7. And I always tend to do that when I'm subtracting. I want to be careful that I don't make a mistake. And I want to kind of lead you into that same kind of thing where you're thinking subtraction. You can't forget that you have to distribute the negative sign to the 7 as well. Okay, so that's then going to be over. I'm going to leave the denominator in factored form, though I know it's going to be x squared minus 9. I'm going to leave it as x plus 3 times x minus 3. And I'm going to simplify the numerator, which is 4x squared, and then it's minus 14x. minus 7, and then that's going to be over. So now you think, all right, well, nothing's going to cancel more than likely with this. So I just put the x squared minus, let me put it as x squared minus 9 down here. And there is the simplified version. Okay, I've got a couple more videos, or a couple more problems to do, but I'm going to do one more. Let me see, I have 3 more. So I think what I'm going to do to get all these done is I'm going to stop right here and pick up with example 3 on the next video. Okay, so be right back.